Hello guys, it's just Mr. Wee again. I'm gonna go through number 5 now with you guys. Okay, so basically it's asking me, so it's asking about these two guys right here. Okay, cobalt hexahydrate and cobalt tetrachloride. Okay, you don't need to know the names, but we're looking at these two guys. Okay, if you guys remember, let me focus on here. Okay, so kind of weird. Okay, if you guys remember, when we heated up the reaction, okay, it turned blue, and then when I kind of froze it and I put it in the water, it turned pink. Okay, that's all you really need to know. What gives it the color is these two guys right here. Okay, these two kind of metals right here, the cobalt and the cobalt over here. It's just which one is which. Now think about it. Okay, so I even asked that. What color is cobalt hexahydrate, and then what color is cobalt chloride? And by the way, for this one, I'm not going to write out the answer, okay? I'm just going to explain it to you, and then you got to find a way to write it for me, okay? That's the deal, right? If I give you this and I explain the answer, you guys got to understand it enough to actually write it, okay? I think that's fair, right? But I still want to kind of help you guys, okay? So here's the deal, all right? So essentially, there's this. If I add heat, right, like I did right here, I mean, look at, I'm adding heat to this system. And by the way, the system is this, okay? I have a reaction that goes from here to here, right? That's the forward reaction from reactants to products. And I also have a bunch of reactions in this test tube right now that go from the products to the reactants. That's why I have a double-sided arrow. It can either go backwards or it can go forwards from a bunch of reactants hitting together and making the product, or a bunch of these products right here kind of hitting together and kind of going into the reactant side, okay? We have a bunch of these reactions going on. It goes back and forth. That's what it means, okay? So right now, look where the heat is. Kilojoules. Where do I see kilojoules? Ah, right here. Okay, it's on the left side right now. That's where the heat is. So think about it this way. If I heat this guy up, right, he turned blue, right? Now think about it this way too. Think about the reaction like the way this young woman has her hands, okay? Here are my reactants and here are my products, right? They're about even. They're at equilibrium. But where is my heat? It's on the left-hand side, right? If it's on the left-hand side, and I'm adding heat, get it? Look where it is right now. It's in this young woman's hand. It's higher. Now the reactants are higher because it has more reactants. Part of the reactants are the heat. So that means I'm increasing my reactant. But the equilibrium doesn't like that, so what it's going to do, it's going to use up the excess heat. We're giving it more heat, so instead of just 50 kilojoules, it's going to be a much higher number. Okay, so essentially this. I give it more heat. What's it going to do? She's going to take this hand and slap it all the way over, follow my mouse, into this hand. Okay? She's going to use up all of her reactants because it's going to go to this side. Okay? Remember like the in-class demonstrations we had? So essentially this. I have a bunch of heat. I'm adding a bunch more heat. So it's going to go to this side. And look what metal is here on the right side. It's the copper chloride, okay, or copper tetrachloride, right? So that means you're looking at this guy. You're looking at his color. And what color did we see? We saw blue, okay? So that actually tells me right there that the copper chloride or tetrachloride is blue, all right? Because, again, if I add heat, okay, so for number 5, if I add heat, if I'm adding heat, my reaction will go in the forward reaction, and then I will see copper tetrachloride, and that's blue. Okay, and I saw the color blue. So, okay, I actually will write it, right? But don't write it just like me, or else I'll know that you just copied me, okay? So, if you add heat, if I add heat, reaction will go forward, to the product, and when I added heat, I saw blue. My product was ClCl4, right? So it is blue. Okay, so that's just for this guy. But what about him? Okay, so again, so if you add heat, reaction will go forward to product. Okay, so if I add heat, okay, just like that young woman's hand right here. If I add, no, not that guy, this young woman, right? If I add heat, my reactions get higher. I have to use it up. I'm going to slap over to the right. That means I'm going to go to the right side, and then I saw that guy, and then I saw the color blue, so that means he's blue. Okay? The opposite is this. Okay? In this case, though, if we go to, because I'm not done yet. I just told you what the color of this guy was. Now I'm not going to write the second part, okay? What's the color of that guy? That means he has to be pink, all right? Because if you look at it this way, if I actually lower the heat, or if I actually lower the amount of heat, right? Like in this case, I froze it. That means I take away the heat, right? Because it's being frozen, right? I take away the heat. What's happening is the reactant side, where the heat is, I'm taking away the heat. So instead of this young woman, I'm going to have the guy. Okay, I lowered the amount of heat there. So guess what? He's going to slap over to the left. So that means that my reactions are going to go to the left. Okay, so my reaction went to the left, and then I saw the color pink. That means he has to be pink. Okay, so try to wrap your head around that. Okay, try to think about what I just said, and then you guys have to add that into number 5. I'm not going to just accept this for full credit. I need to see this guy. Okay, what color he's going to be, right? Okay, we said he's pink, but why? Okay, all right, guys, good luck with this. Hopefully that helped. So if you guys have any more questions, see me at lunch tutorial tomorrow. Okay, have a nice night.